All right, so this video is going to be going through simplifying exponents, but with non-like bases. It was a request that I had to make this video. So what I want to look at is this first example, and what I've got here is a base 3. I've got a base 3 here, and I have a base 3 here. So because these are all like bases, I can just work with the exponents using my normal exponent rules. So in that numerator, I have a base 3 times another base 3. Those are the same bases, so I get to add the exponents together. So I've got 4x minus 3 plus 2x. So that's going to turn into 6x minus 3. So I'm going to rewrite that denominator. So 3 to the 4 minus x. Again, still have the same bases here, right? 3 in the numerator, 3 in the denominator. Exponent rule says if you are dividing like bases, you want to subtract the powers. Now this one I'm not going to do in my head because I sometimes will make mistakes with subtraction that I don't want to have happen here. So I've got a base 3, and I have the 6x minus 3 from the numerator, and I am subtracting the 4 minus x from the denominator. Now, if you don't need to do that step, feel free to skip it, right? It is not required in any way, shape, or form. But now I want to actually combine those pieces. So I've got 3. That 3 hasn't changed in this entire problem. Keep that in mind. We've got 6x here minus a negative x. So minus a negative really becomes plus. So I'm looking at 7x. And then I've got negative 3 minus 4, and that would be minus 7. Now, one thing I noticed is sometimes students will want to turn this into an equation and try and solve things. This was never an equation to start with. So these equal signs are just what's happening as I am changing this part of the problem into the next step, and then the next step, and then the next step. But it's not an equation, all right? It's just showing that these pieces are equal. And so at the end here, this expression, you can't tell me what x is equal to. So please don't try, all right? There's nothing there for you to actually solve. You are simply simplifying this expression. So this is an example of how to work with the like bases, which isn't too painful, hopefully not too bad. You basically just work with your exponent rules. But what happens when those bases aren't the same? And so example 2 here, we've got a base of 2, we have a base of 8, and we have a 32. That would be a base as well. So what I want to do here is actually rewrite all of these with a common base. And so I'm looking to see how can I rewrite a 2, an 8, and a 32 with all the same base. And I'm pretty sure that 8 is really 2 to the 3rd, and 32 is 2 to the 5th. Okay, and so what I'm going to do is a little substitution. So the 2 to the x is going to stay 2 to the x times. Now instead of writing 8, I'm going to replace it with 2 to the 3rd, and then also pay attention to this exponent of 3x here. That's not going to disappear. And then in the denominator, I have 32, and that would be replaced with 2 to the 5th. Now I'm in a situation where, just like that first example, I have all like bases, and so I can work with just the exponents. So my first thought is I need to deal with an exponent, right? My power rule here. And so that's going to tell me to do 2 to the, I need to multiply these exponents together. So 2 to the 9x all over 2 to the 5th. Okay. In the numerator, I have 2 bases, like bases being multiplied. So I'm going to combine the exponents by adding. So that's going to be 2 to the 10x over 2 to the 5th. And last step here, I am dividing like bases, so I need to subtract the exponents. So this is going to turn into 2 to the 10x minus 5. And at this point, I have reduced this problem. I've simplified this problem down to just having a single base with a single exponent. So this is as simplified as I can make this without having any kind of an equation or knowing what x is equal to. All right, I've got one more example here. So let's go ahead and scroll on down. And in this case, we've got 8, we've got 64, and we've got 4 as the bases. So this one's a little tricky because it looks like you might have a couple of things that might work. So 8 squared 64, but I'm not going to take 8 to some power to get 4. That doesn't work, okay? I'm definitely not going to use 64 to some power to get 8 or 4, so let's not work with that one. 4 to some power to get 64, yeah, 4 cubed is 64, but I can't do 4 to some power to get 8. So this is a little bit weird, but what you could do is turn all of these into base 2s. So 8 is 2 to the third, 4 is 2 squared, and 64 is 2 to the 6th. All right. So this is really the trickiest one that you're going to see, where none of the bases that are given are actually the base you want to work with. So see what you can figure out. I'm going to replace 8 with 2 to the third. Keep the x minus 2. 64 is getting replaced with 2 to the 6th. Keep the 2x plus 5. All over, 4 is going to get replaced with 2 squared, and I'm going to keep 3x plus 2. Now, not only did I make the bases more complicated, I was a little bit mean on this problem, and I did make the exponents more complicated as well. So for each case here, I need to take the exponent that was used for the base 2 and multiply it times the given exponent, right? Multiply these out, multiply these out. So let's see what that turns into. All right, so my screen keeps trying to roll on me here. So 2 to the 3x minus 6 times 2 to the 12x plus 30 over 2 to the 6x plus 4. I'm going to keep rolling over to I'm going to keep scrolling to the right here. So now I'm going to deal with my numerator. So this is going to turn into 2, and I'm going to add these exponent expressions together. So I've got 3x plus 12x, so 15x. Negative 6 plus 30 would be plus 24 over 2 to the 6x plus 4. All right, I'm going to subtract my exponents because I'm dividing the like bases. So 2 to the 15x plus 24, right, minus 6x plus 4. And I've officially run out of room going to the right, so I'll just slide underneath. So 2 to the, all right, 15x minus 6x, 9x, and then 24 minus 4 would be plus 20, plus 20. And that is as simplified as that expression becomes. So I'm going to pinch in. Now, if you can do parts of these problems in your head, maybe you can skip this step of writing out the subtraction and you just do from here to here. Okay, great. You might be able to get from here to here. It really depends on how much you can keep track of in your head. I will say this. If you start making mistakes in problems, and because you're skipping steps, stop skipping the steps and show your work. I hope this has helped. This has been simplifying expressions using exponent rules with non-like bases.